Vertical takeoff aircraft have a most colourful history. We explore a couple of the more quirky attempts of VTOL. Today, nearly anyone can buy and fly a remote-controlled aircraft. But in the late 1920s, this was extremely high technology. We find out how RC was developed. Lastly, we look at how aircraft can mutate from one shape to other shapes, and how and why mutation occurs. There are many interesting stories in the quest to build vertical takeoff aircraft. The Curtiss X-19 is one such example. The Curtiss-Wright X-19 began as a commercial venture. The four propellers were powered by two turbines and rotated 90 degrees at the tips of two thin wings with a 6-metre span. The X-19's performance in the airplane mode was disappointing. It flew a mere 50 times, which totalled about 4 hours flying time. The first prototype was damaged on its second flight in November 1963. During August 1965, the aircraft crashed again, this time into a nearby swamp, and was totally destroyed. The second aircraft was never flown. The idea of various bits of the airframe to supply both vertical takeoff and inline flight has been repeatedly applied to the entire wing, including the engines. This allows a less artificial position rather than just sticking the engines on the end of the wing. This is perhaps the most common design in the early days of VTOL. The big drawback was that the wing had to be transitioned to go from hover to inline flight, and this proved to be a risky procedure. The critical moment is when the motor ceases to provide lift before the wing is able to supply lift for inline flight. The Vertol 76 was developed as a test aircraft for the US Army and Navy. It flew from 1957 to its retirement in 1965, and in that time it made hundreds of successful flights. The Vertol 76 was quite an influential plane. Much work was done to get the plane right, and it was very stable. These developments were crucial in further development projects. Tilting ducts were another theme in the history of VTOL. A similar idea to tilt props. The ducts did have several advantages, but most importantly, they actually added wing surface in level flight, which meant more lift. Vanes within the ducts could be manipulated to help with the delicate transition from hover to flight, and turbulence was also reduced compared to the conventional propeller. The Doak Model 16, which was completed in 1957, was among the most promising of the early trials of VTOL. During the Doak trials, it became clear that the power required to build a useful VTOL aircraft was substantial, and the task of building such a plane was going to be an enormous undertaking. The jet age was looming, and this was a turning point in achieving workable VTOL. The fan idea was a natural progression when coupled with the jet engine. This is a Ryan Turbo XV5A. Engine gases from two turbojets were sent to exit by turning fans. There was a large fan in each wing with covers resembling half garbage can lids, which flipped up for vertical flight. The nose fan provided adequate pitch control, but made flying tricky. The fans provided vertical thrust, and a set of louvered vanes under each of the large wing fans could vector the thrust in any direction and provide yaw control. Roll control was by differential actuation of the wing fan exit louvers. One XV5A was destroyed during an official flight demonstration in April 1965. A rescue version, which would winch a person into a compartment behind the pilots, was also tested. This plane was extensively damaged in 1966 during trials, when the dummy was ingested into a wing fan. This second plane was rebuilt as a modified XV-5B, with tests continuing until 1971. This is sometime during World War I, and this is the world's first flying bomb. It was referred to as the Bug, and the project was supervised by Orville Wright. A young military officer involved was Hat Arnold, who would later himself become an aviation legend. Regardless of the involvement of the two great names in aviation, failures were experienced. The Bug did work occasionally, and it was doubtful the Bug itself could cause an enemy to be really concerned. The Bug's importance in the history of aviation is what it heralded. By the 1930s, when this drone was built, a major problem of the Bug, which was a lack of guidance, was overcome. This was, in fact, perhaps the world's first radio-controlled plane. Today, RC planes and helicopters are a common hobby, but in 1930, this was a very real breakthrough. This unit used a telephone dial to send selected signals to the little plane. The concept of this drone was for target practice, and its operational viability was weighed up by cost and the ability of the drone to do its job. It was simply going to be made to be destroyed. Remote control was not advanced enough to land the plane conventionally, so this is how it was done. However, it wasn't until World War II that a flying bomb was born. The V-1 was the first guided missile used in war and the forerunner of today's cruise missile. V-1s were launched from ski jump launch sites along the French and Dutch coasts until the sites were overrun by Allied forces. On the 13th of June 1944, the first V-1 struck London next to the railway bridge on Grove Road, Mile End. 8 civilians were killed in the blast. Almost 30,000 V-1s were made. Approximately 10,000 were fired at England. 2,419 reached London, killing about 6,184 people. Fighters were mobilised to intercept the V-1, but most fighter aircraft were too slow to catch a V-1. The first interception of a V-1 was by Flight Lieutenant Musgrave on a night in June 1944. The US reverse-engineered V-1s by inspecting wreckage found in England, and a first test flight of a US V-1 was conducted less than 4 months after the first V-1 attack. The first flights were from Eglin Air Force Base, Florida. However, extensive testing was also done at Wendover in Utah. The US Navy conducted experiments to mount V-1s on submarines. This was the American Doodlebug. It was built in conjunction with Republic Aviation and the Ford Motor Company. During the war, the Americans also worked on their project of early smart bomb or missile. These were glide bombs, which were radio controlled by the bombardier while in free fall. Another venture of drone experiment employed what were referred to as Weary Willies. These were large bombs that had reached the end of their lifespan. They were retired in a most spectacular way. They were packed with explosives and then flown by remote control into a target. The concept of V-1 and drones in general led to the idea of developing battlefield scout aircraft. The idea was to arm the vehicles with television instead of bombs and simply flown over an area to give the infantry a bird's eye view of the enemy. The idea was to minimise the risks to scouts and maximise intelligence of the enemy's movements. Vietnam saw the development of several types of spy drone. The North Vietnamese were very well armed. with advanced ground-based anti-aircraft measures already tested in warfare, so flying over the north became increasingly hazardous. The answer: small drones. These flew over the area and recorded important reconnaissance information. Between 1965 and 1975, over 3,000 flights have been conducted by these small remote-control pilotless planes. Over 200 of them were shot down, which could have been two main reconnaissance planes or Wild Weasel aircraft. There is no doubt that drones saved American servicemen's lives. The drones could fly sweeps over heavily defended areas. They flew quite low at speeds of about 500 miles an hour. Other drones were used to fly over the area to jam radar and expel chaff to render the enemy's early warning system as useless, immediately after a bombing raid was conducted. After a mission, the drones were directed back to friendly airspace and retrieved by helicopter. The operation was difficult and dangerous, and was perhaps the only flaw in the spy drone concept. The drone's weight, which was reasonably significant, didn't help the recovery technique. The drone of Vietnam are the direct descendants of the most advanced drones used in the current Middle East conflicts. Perhaps the only safer way to recon an area is with satellite imagery, but this has its own inherent problems. So even today, the humble drone is still an important piece of ancillary equipment on the battlefield. Perhaps one of the most interesting flying bombs that should be mentioned is the TOR. It was a very unsuccessful piloted plane design. The manufacturer did manage to interest the US military of its use as an anti-shipping weapon. The TOR used television and remote control and was sophisticated for its time. The operator used the television images to fly the plane, but it wasn't fully accepted by the military. After the war, private companies bought up TORs and transformed them back into piloted planes, as the actual aircraft was really a very good product. This is a military test of a TOR which is being flown via the hazy television image by the remote operator. The mutation of aircraft is an ongoing thing. Nearly every model of plane has advanced variants of the original, but some mutations are more severe. Sometimes there are even one-off mutations which are developed to test a single idea before further development of an entire project begins. This is a Flying Fortress testing inline engines. This is a P-47 testing counter-rotating props. Another area of mutation is not specifically directed to a single plane. An example is addressing solving the problem of landing fighters in mud, which damaged many and slowed down operations. A series of tests were conducted to find a better designed undercarriage for muddy conditions. What was learnt here was actually carried over to many different aircraft. So a design that solved one problem overcame many. A more dramatic mutation can be seen when the particular characteristics of one aircraft is carried over and into a completely different plane. In this instance, much theoretical and expensive research is carried over from one design to another. The famous P-38 Lightning, one of World War II's best fighters, was very influential on the development of another aircraft, the much bigger Twin Forks Devil from the Lockheed stable, the chained Lightning XP-58. This plane was designed to be a fighter-destroyer. The Chain Lightning was further developed to be a long-range escort fighter, but it was too large to be able to undertake dogfighting, so plans were then drawn up to use it as an anti-shipping weapon. However, enthusiasm for the whole design was losing favour. The legacy of the P-38 is visually evident in the Chain Lightning. It was larger, and it did have a second crew member positioned in the turret at the rear of the fuselage. And a cruising range of 2,600 miles, the XP-58 had good performance for its day, but weight let it down. Too heavy for a fighter, and not large enough as a bomber. Another type of aircraft mutation is when one aircraft is used as a test bed for parts or ideas that are being developed for an entirely new type of plane. Here, a B-26 is being used to test the undercarriage for the B-47 jet bomber. Some of the most interesting mutations occurred in planes of the same type. This occurred when new technology was to be used to upgrade an aircraft, or right problems with the original design. The English Canberra was selected as the B-57 for the US Air Force. The Martin Company was contracted to build the aircraft in America. The Canberra was an exceptionally manoeuvrable bomber, but it had some problems that needed sorting. One problem was the positioning of the crew. It would have been highly unlikely the crew could abandon the plane in an emergency. So over the ensuing year, the Martin Company addressed this problem and a number of others. A rotating bomb bay was also included, and better avionics, which turned the plane into a nighttime intruder and recon plane. This adaptation of the original B-57 went on to play a minor but successful campaign in a Vietnam conflict. But this is not the end of the B-57 story of mutation. Later, the famous U-2 spy plane program was delayed. So in the interim, it was decided to give the B-57 a much larger wing to make it a high-altitude spy plane until the U-2 was available. This variant became known as the B-57D Big Wing. The wingspan of the D model was more than 40 feet longer than the original. It performed so well that even when the U-2 became available, the B-57D was still used in a complementary role. The B-57D could carry more load than the flimsy U-2, and it was ideal for use in electronic information gathering. There was one problem with this mutation. It suffered severe wing spar stress, and the entire wing arrangement had a short lifespan. So another mutation of the B-57 Canberra was brought forward, the B-57F. This plane had a wingspan over 20 feet longer than the D model and nearly twice the length of the original aircraft. The Canberra is just one example of continued mutation. Hitler's designers who worked on his planes and weapons of terror created much military hardware that led straight to the modern day. The Germans built and tested many designs. Not all were feasible, but they learnt much, even from the failures. After the war, the researchers and the scientists took up residence in both the Cold War's players, Russia and America. The UK also received a number of these scientists and designers. Their work went on to be refined, and these are the roots of many of our modern armaments. In matters of rocketry, they made a number of significant breakthroughs. They sorted out reliable power plants for their missiles and reliable mechanicals for the complete units. The Germans made great strides in control mechanisms, which consisted of radio controlling and jamming-proof controlled wire systems. These systems were newly developed and a lengthy training program was required to get the operators and ground crews proficient with the use of this early remote control apparatus. The early testing of this remote control weaponry proved that the systems would be a menace to the Allies in many areas. But shipping would have been the obvious target of the early remote control bombs and missiles. The wing extensions on the wing of this model are for wire spools. This missile is physically connected to the controller in the parent aircraft. From this test, it is easy to see how much havoc these weapons could have wreaked. They were very accurate for their time. This is the H-293 and was used with both radio and wire control. The wire system required miles of fine wire that spooled out from both the aircraft and the missile in two strands. The wire-guided missiles had the advantage in that radio jamming could not interfere with the operator guidance of the missile. The HS-293 was developed to a more powerful version. This version was fitted with two rocket engines. The twin engines gave the missile a much higher speed and made it usable as an air-to-air missile. The Luftwaffe saw great potential in the air-to-air missile and spent much money on the concept. The idea was perfect to knock down Allied bombers, and again they remained with wire guidance. This missile was designed to rotate in flight, which wound the two strands together behind it. The missile was designed for use with the night fighters, but there was no reason it couldn't be used on the day fighters as well. The systems were still in their infancy and problematic to use. In hindsight, the Germans would have been better off refining their jet fighter and 20mm cannons, which would definitely affect the Allied bombing runs. Regardless, it was this pioneering that hastened the advance of guided missile during the Cold War.